Hello everybody, my name is Ash and I'm with the 2-Bit Circus Foundation and I'm so excited to walk you guys through the basics of laser cutting with Retina Engrave today. So before we get started, I just want to talk to you a little bit about why laser cutters are great for a classroom environment and also what are some of the things you can make with a laser cutter. Laser cutting is an advanced tool of digital fabrication that allows users to accomplish really impressive works of advanced material construction and fabrication. So that can be materials including wood, metal, acrylic, things that would normally take a student or even an adult a pretty long time to learn and be able to construct something with them in a rapid process. Laser cutting is a really useful tool for the classroom because it not only teaches things like cooperation and creative engagement, but it also encourages students to follow their own creative storytelling and utilize a technical knowledge that converts digital information into physical reality. Laser cutting is also very useful for the classroom because it allows you, the teacher, to produce a lot of your own classroom materials rather than having to go out to purchase them. You can create physical 3D models, dioramas, boards for your classrooms, name tags, so many things. So just to give an example of some of the things you can create with the laser cutter, this is an example of 3 of the processes in laser cutting we will be talking about today. So you see you can create some cutouts, you can also etch into material, and you can create an image in material. You can create a etching that has fill to it. So yeah, we're going to talk about all of that today and how you can go about doing that and how you can introduce laser cutting to your classroom in a way that is safe and fun and effective. Laser cutters operate using 2 main types of processes, cutting and etching, and rastering. When using a laser to cut or etch, we notice that the laser follows a specific path that we created inside of Retina Engrave, utilizing tools like lines, shapes, texts, in general, outlines. These different types of entities in computer graphics are known as vector paths, and because of that, cutting and etching are referred to as path-driven processes. We can use cutting and etching to create precise outlines or shapes created in vector-based software like Adobe Illustrator, Retina Engrave, or Inkscape. Cutting will fully penetrate the material, allowing part of the material to be removed, whereas etching will only burn away the top surface of the material. These processes are ideal for creating intricate patterns and designs, stencils and parts, and adjustments to these processes can be done by changing the laser's power, current, and speed settings to match the material's thickness and hardness. To contrast, rastering is a pass-driven process. Just like how a regular paper and ink printer operates, the laser carriage will move back and forth in a repetitive pass system, filling in areas of the material with blasts of the laser. This in turn produces an image, or it can produce an image of text, or a shape, or whatever may have you. You can use a raster process with image files, so PNGs, bitmaps, JPEGs would all be appropriate to utilize for a raster. You can use rastering to create detailed designs like logos or photos inside materials like wood or acrylic. To adjust settings for a raster's quality, you can adjust the DPI, or the resolution of the image as it's being rastered, or you can also adjust the power level of the image. In order to get started with your laser, you first have to access your design software. To do so, you're going to want to locate the IP address which is associated with your laser. In order for this process to work, the computer that you connect to your laser with must also be on the same Wi-Fi that your laser is connected to via Ethernet. To locate your IP address, you can find it in the top left section of the blue ribbon at the top of your touchscreen, underneath the main settings. For me, my IP address is 192.168.12.158. This is just one example, but your IP address will be a series of numbers with a series of periods in between. Once you've collected the IP address on your laser cutter, you can now go onto any browser on your computer. It can be Microsoft Edge, Firefox, Google Chrome, doesn't matter. And then type in that IP address into the search bar for that browser. So that's what I'm going to do right now for my laser cutter. So for my laser, the IP address was 192.168.12.158. And if I go ahead and hit enter, it's going to then take me to our design software. All right, everybody, welcome to Retina Engrave 3. I'm so excited to get to share this to you. For those of you who have worked with tools like Adobe Photoshop, Adobe Illustrator, anything like that, this might seem a little familiar. In fact, even for those of you who might be a little more savvy with things like PowerPoint or Google Slides, you might find that this has some similar tools. But don't worry, we're going to be going through all the basics today. Let's spend a little time talking about the anatomy of our design software and understanding what all the parts in front of us really are. So, this white area in front of us is our workspace. It's where we can actually create the design that lives in our project. Retina Engrave comes with 4 toolbars you should be aware of on default. There's the left toolbar, the right toolbar, and then there are 2 toolbars on top. The uppermost toolbar is one you've probably seen in pretty much every program you've used. It's your file toolbar. It lets you do things like importing objects, loading files that you've already created, creating new files, exporting projects to files, so on and so forth. Let's spend a little time talking about this lower top toolbar though. That's known as the Tools toolbar. It's grouped by color, so each color represents a different kind of tool that you can utilize. All of these tools are relevant to your time in Retina Engrave. However, I'm going to go over the ones I think are most important for you to know. So starting on the far left, we have the light green toolbar. This toolbar lets me do things like import images, select materials, undo operations, redo operations, so on and so forth. Effectively, it's a systems operations guide and toolbar set. Now you also have this light gray toolbar. These tools are your laser preview tools. They let you do things like estimate how long a laser job will take or run perimeter to see how your design fits within the boundaries of your material. Additionally, this is where you can actually start your laser job by pressing this blue button. Along with that, you have the pink toolbar. This is your view tools toolbar. This allows you to change the viewing parameters of your workspace. So I can increase the zoom, I can have it fit my screen, I can pan around by grabbing it using this hand tool. I can also use a snap feature. And this makes it so that way the objects I draw in my design software will snap to the grid lines I've produced to create a really tight, consistent grid of shapes and forms. And now we have the blue tools. This is really the holy grail of Retina Engrave. These are the object creation tools. Among them are the pointer tool, which lets you select objects, the shape tool, which lets you create lines, rectangles, ellipses, polygons, triangles, and stars, the pen tool, which lets you create curves and lines by freehanding them so you can freehand your own shapes, the knife tool, which lets you cut shapes into different pieces and thereby segment them into different sections, and the text tool, which lets you, like any text box, create a series of text that can conform to any settings of font, font size, and spacing. So to show you this next set of tools, we have to actually have some graphics in our workspace. So I'm going to go into my shape tool, and first I'm going to create an ellipse. And I'm going to do that by selecting the ellipse button and then pressing the left key on my mouse and dragging my ellipse. Additionally, I'm going to create a rectangle by going back to my shape tool, clicking rectangle, pressing the left key on my mouse and dragging my mouse to create a rectangle. Great. And you know what? I think I'm going to add a little text in here too. So let's go ahead and make some text. It doesn't have to be anything crazy. And let's just go over to the right toolbar, which we're going to talk about more in a second. But for now, all you have to do is just increase your font size. Let's make it really big. There we go. Great. So let's talk about these other tools. When I click on any of these shapes, I get access to the orange tools. These are your object manipulation tools. They let you do things like reflect and rotate objects. If I click on multiple objects, so I can either click one, shift click on my keyboard, and then click another, or I can drag my mouse while left clicking over all the objects I want to select and then let go. I now have access to these group and combine sections. These tools allow me to group objects together or combine them into one form. And I can use different parameters to define their combination. So I can subtract one from the other, I can see the intersection of two shapes, I can even take the difference of them. For now, I'm going to use union. And you can see it just combined my circle and my square into one compound shape. And so I just undid it by hitting Control-Z on my keyboard. The last set of tools I would like to talk about are the arrangement tools, which are these purple set of tools right here. These let you control the order that objects are arranged in. So let's go ahead and take one of my shapes, and I'm just going to change its color really quick. Don't worry too much about how I'm doing this. We're going to go more into detail about it later, but I just want to illustrate that if I zoom in here, you can see one of my shapes is definitely in front of the other, or on top of it. That's the whole concept of layers in a design software. One of these shapes is on a higher layer than the other. But sometimes I want to access the shape on the lower layer. For example, let's say I want to click this circle, but I only wanted to click the region inside the square. If I try to, all I can click on is the square. But with my arrangement tools, I can send that square backwards to a lower layer or bring it forward to a higher layer. So I'm going to send it backwards. And now I can click on my circle. Those are the tools you need to be aware of for the Tools toolbar. Additionally, there is one other set of tools that I'd like to discuss with you, and that is your alignment tools. That's these 6 tools here. They're useful for when you want to align multiple objects together. So I can have a left alignment. So now their left edges are aligned. I can align their centers or their right edges. I can also align them by their top edges, their middle centers, and their bottom edges. So typically, if you want something, for example, concentric, you probably want to align the middle and align the center. So that is everything you need to know for the upper toolbar. Now let's talk a little bit more about the left and right toolbars. The left toolbar, otherwise known as the workspace toolbar, is where you can see your list of projects and also your layers. So like I mentioned earlier, layers are a tool in graphic design software where you can effectively have objects stacked on top of each other. This is what allows us to know which object is on top. The object that is on the top of the layers list is also on the highest layer, which means if I stack all these objects on top of each other, that's the object I'm going to be able to click on. If I want to access a specific object, I can just go to my layers list and click on one of them. So if I want to access my ellipse, I can just click on my ellipse directly. Additionally, you might have noticed that every time I click on a different object, my right toolbar seems to change. That's because the right toolbar is what's known as the parameters toolbar. On default, if I don't click anything, what happens is I have a default parameter setting for my project as a whole. It shows me my project name, it shows me all the colors and various settings for all the shapes I have present in my design software. It's a general view. But if I click on any of these entities, for example, text, now it populates with all the parameters that are relevant to this text box. It gives me the position, the size, it gives me the font type, it gives me the font size, it gives me font manipulation, so bold, italics, underline, strike-throughs, it gives me alignments, it gives me spacing, pretty much everything you'd see in a normal text box. In contrast, if I click on one of my shapes, so for example my rectangle, you'll notice I still get position, size, angle, and anchors, but I also get things like infill and outline. I can round my corners, stuff like that. Things that are only relevant to a square. So what I'm trying to illustrate here is that the right toolbar as a parameters toolbar will always be dependent on what you have selected. So if you want to just see what the default settings are for your entire project, the easiest thing to do is just click any of the white space and it'll reset to it. Now that we've gone through the theory behind how laser cutters work, let's start talking about how we can actually tell Retina when we want to cut, etch, and raster different parts of our design. If you remember earlier, I said that cutting and etching are associated with a graphics object that we call vector paths. In design software, a vector path is one of the most fundamental units of any type of graphics object. Effectively, a vector path is just a line. It can be a straight line, or a curved line, or lines that form a shape, or lines that form text. Effectively, vector paths are just outlines.
Now let's make a simple vector path inside Retina Engrave that we would like to cut out of our material. So to do that, I'm going to go over here to my blue toolbar, and I'm going to click on this drop-down menu. And I'm going to select the ellipse tool. To set my ellipse, I'm going to place a portion of it on anywhere on my workboard. In this case, I'm going to put it right here. And then I'm going to drag my mouse. And as I do that, you can see I'm forming an ellipse of varying x and y parameters. If I want to lock those parameters so that way they scale proportionately, and this doesn't just work for ellipses, this works for every shape. If you want to create a proportionate scale, just hold down Shift while you drag your mouse too. So right now I'm holding down my left mouse button, I'm holding down my Shift button on my keyboard, and I'm dragging my mouse back and forth. And this feels like a pretty good size to me for a circle, so let's go with this. Now I'm going to click on my workspace, just so I can reset everything to the default layout. So I've drawn a circle. You'll notice that once I've completed drawing this circle, a new tab forms under Vector Engraving Parameters on the right toolbar. This tab shows a box with a color, a speed number, a power number, a current number, and a number of passes. This tab is basically telling me that any vector path that has this associated line color or stroke color will have these associated speed, power, and current levels attached to it. So if I were to make another square, or another circle, or a polygon, or a triangle, or a star, if it's the same color as the color defined here, when I send it out to the laser will look at my design file and say, okay, every shape that's orange should have 100% speed, 100% power, and 100% current, and I should go over it 3 times. Effectively, these settings are what let us control the power of our cuts. We can have multiple objects of multiple colors, and those different colors can correspond to different power settings. Now, before we dive into an example of that, I want to just take a quick moment to talk about what these numbers actually mean for speed, power, and current. As a general rule, speed controls how fast the laser moves, and you're almost always going to keep it at 100. This is because we just don't want any section of the material heating up too much. Current controls how deep a cut will go, whereas power controls how dark the cut will become. Normally, those two numbers are almost always the same. For my material, I know that a speed of 100, a power of 100, and a current of 100 with 3 passes works pretty well to do a cut, so I'm going to leave it at that. But for you, for whatever material you're using, you're going to have to figure out the appropriate settings for it. Generally speaking, there are some guidelines you can follow, especially if you look online, and we'll be talking about that more in the tips and tricks section. Now, that being said, let's actually see an example of when assigning new colors to different shapes can allow us to have a lot of different things going on in one design file. So right now, we just have one simple shape being cut out, a circle. But let's say I wanted a concentric circle inside of that circle that was etched. So it was a cutout circle with a circular ring inside of it that's been etched. Well, to do that, I'm going to go back to my blue toolbar. I'm going to go to my ellipse tool. I'm going to go and create a new circle. And so you'll notice I only have still one color under my vector engraving parameters. That's because Retina Engrave defaults all objects to the same starting color of orange. But I don't want this inner circle to be orange. If it's orange, it's going to be associated with orange power levels, which mean cut. I want new power levels for a new color that tell it to etch. So what I'm going to do is I'm going to select my inner circle, and I'm going to go and select the color that's associated with it. And I can do that under the Vector Engraving Parameters window. This is important. If you want to change the color of a specific shape, you have to click on that shape specifically, and then you can access its color through the Vector Engraving Parameters window, which makes sense because we know that when we click on anything in Retina Engrave, the right toolbar populates with parameters relevant to what we've clicked on. So it would make sense that the color we see once we've clicked on an object in the right toolbar is the color associated with that object. Let's go ahead and change it to something really different than orange. I'm thinking blue. Okay. So now I have a blue circle, But you'll notice my speed, power, and current settings are still all at 100. That's just because that's what Retina defaults it to. So, if I click on my whiteboard, you can see all of the colors I have present, but I don't want two colors that basically mean the same thing. I mean, right now, that's what orange and blue are saying. They're both set to 100 everything. The only difference is the number of passes. So, since I want this to etch, I'm going to reduce the power and current level. Now, generally speaking, it's a good rule of thumb, especially for wood, to reduce power and current by about 50% when you want to turn a cut into an etch. And like I said earlier, we like to keep speed at 100, so I'm going to keep it at that, and I'm going to keep number of passes at 1. And this is looking pretty good, but I also want to align my circles so that way they're perfectly centered. So to do that, I'm just going to drag over everything, and it will select everything. Or I can click one object, hit Shift, and then click another object, and it will select both. And I'm going to use these alignment tools on the top right of my right toolbar. So there's align left, align center, align right, align top, align middle, and align bottom. I'm just going to go ahead and align center and align middle, so that way they're perfectly concentric. And there we have it. We now have two different objects with two different power levels associated with them. And when I send this out to my laser, it's going to read them and say, okay, I should cut this larger circle with the orange power levels, but I should etch this smaller circle with the blue power levels. So, to recap, cutting and etching is a vector path-driven process where truly the only difference between them is the strength of the power and current level. The shapes you create with them, the entities you create, the graphics themselves, are practically the same. So, now that we understand all this, let's go ahead and send this out to the laser cutter and see what it looks like in real life.
And so there you go. That is a circle with another circle etched inside of it. So that's an example of doing vector cuts and vector engraves with a laser cutter.
So we spent some time talking about etching and cutting. Now let's switch to the other side of lasers, rastering. Like I mentioned before, rastering is a pass-driven process, not a path-driven process. It is pass-driven. To begin rastering, you have to go into the Import Image button and import an image from your computer. Now the Import Image button, which is located in our light green toolbar, it's actually the very first tool in our toolbar, is right here. So I'm going to go ahead and import an image. I already had prepped for this that I grabbed from the internet. It is a logo of my company, the 2-Bit Circus Foundation. So this specific image I imported is a .png file, but you can use any type of image file and it should work. So what you want to do when you're trying to create an image inside of Retina Engrave is first enlarge it to the size that you feel comfortable rastering. For me, this feels a little small, so I'm going to do what I did previously for changing the circle size, and I'm going to hit Shift on my keyboard, hold down my mouse, and drag my mouse out to scale proportionately. That feels pretty good to me. Now, you might notice that there are flashing zones created around the border of your image whenever you import an image into Retina Engrave. These are effectively tolerance zones for the laser. When the laser is moving, it has a certain amount of momentum, and because of that, it needs to have a certain amount of space so that way it can reliably stop itself. So, these flashing regions represent the maximum amount of overshoot the laser carriage can engage in. Generally, in order for a laser cut to work for a raster, you have to have both of these zones within your white workspace. So I'm going to drag my image until both these zones are green, which they now are, because now both of my overshoot zones are within the boundaries of my workspace. I'm now going to actually look at the raster properties. So before, we had vector properties on our right toolbar. Now, if I click my image, I get raster properties. Now, you don't actually need to worry about the majority of these properties. The only settings you need to worry about are resolution, power, and speed. Resolution controls the quality of the image. It's kind of similar to the resolution of an image on your computer. The higher the resolution, the better the quality, but also the longer the cut time. Generally, I like to keep things at 500 by 500, unless I'm doing something really nice, then I'll do 1000 by 1000. Power is kind of what vector power and vector current were combined. So it controls how generally dark your image is going to be, and it also controls how deep the raster goes into your material. Speed, like we said before, is just how fast the laser is moving, and again, we like to keep that at 100 just because we don't like leaving the laser in one area for too long, because it may overheat the area. So this is actually all you need to do. This is all you need to do to raster an image. I could hit play and send this out right now to my laser. So, to recap, we've discussed how cuts and etches are made by vectors, and rasters are made by images. But what if I want a filled shape? So far, all we've talked about are outlines, how to cut and etch them, and we've also talked about images. But what if I want, for example, a circle, but I want the laser to burn away the top layer of surface material and give it a dark fill, rather than leaving it the natural material color? Well, we can do that too. What I'm about to go over is a special case. It's pretty much the only special case you'll need to know, but realistically, your students are going to want to make shapes that have fills in them. To make filled shapes, we're going to take a vector path and we're going to convert it to an image that we can then rasterize. So, in order to do that, let's first clear off our board, and we're going to go ahead and make a circle. So just like before, we go to our blue toolbar, we go to our little caret icon for the shape tool, and we click ellipse, and we draw our ellipse. And now I'm going to start doing some things a little differently. We're going to click on the ellipse, and on the right toolbar, you're going to notice a section called Vector Fill and Rasterize. There are some components here that we're going to need in order to pull this trick off. First, we want to actually create a fill in our vector. That's the whole point of this, right? We want to have a shape that has a fill. So, if I go to the infill tool, there's a series of different types of infills I can produce. It actually doesn't really matter which one you use, as long as your spacing is 0. If it's not 0, then it'll change the look on the final output, but most of the time it'll be 0. So I always just use horizontal lines. And now I have a filled in vector. This still isn't an image yet, it's just a shape with a fill. It's still a vector technically. So to convert it to an image, I would have to go back into Vector Fill and Rasterize, and while the circle is selected, click the Rasterize button. And so rasterize is a process where a vector path is converted to a pixel-based image. This is now basically a picture of a circle. It's the equivalent of if I screenshotted my previous circle, which was a vector, and then imported it back in here. And now, when I click on this circle, you'll notice it has those flashing zones that represent the raster overshoot zones. And additionally, it has raster properties in its right toolbar. Finally, you'll notice that the shape itself is under a new group called Rasterize Group in the Layers and Objects bar of the left toolbar. This is all ways you can check to make sure that your shape was correctly rasterized. So, now that I have a shape that is fully rasterized and filled, if I send this out to my laser, it will go ahead and produce a circle with a consistent value fill. Now, some of you might be thinking, that's cool, but I still want my filled circle cut out. Will this do both? And the answer is not yet. We just converted a vector that was filled into an image. It's fully just a picture now, including its edges. So there's no longer a path for the laser to follow. To tell the laser I want to fill this circle and cut it out, you have to make the circle twice and stack the outline of the circle on top of the filled image of the circle. So I'm just going to look over here on my right toolbar properties and see that my circle has a width of 3.3394, and I'm actually just going to copy that dimension. And then I'm going to go and I'm going to make a new circle, just like I did before, and I'm going to make sure it has the same width and height. And so this circle that I've drawn now is a vector. We know that because when I click on it, it shows vector engraving parameters in its right toolbar. And in this case, it defaulted to the settings I need for my material, so I'm not going to change it. But I am going to stack one on top of the other. So I can go ahead and select both of them, and then align their centers and align their middles. And now they're stacked on top of each other. And I know they're stacked on top of each other because if I look at the Layers and Objects section of my left toolbar, it shows two objects, a rasterization group and an ellipse, which is a vector. So now that we have a filled shape and a vector path to cut it out, we can actually send this out to the laser right now and see how it looks. So let's go do that.
All right, and there you have it. That is our filled circle that we were able to create by converting a vector into an image. And so you can see for comparison how it looks to the non-filled circle. So it's way darker on its top surface because it rastered away that top surface of material. And there you have it. Now, we have covered a lot up to this point in the tutorial, so let's do a quick summary on rastering versus vectors.
As we discussed earlier, there are two modes of laser operations. There are path-driven laser operations and pass-driven laser operations. Among them are, for path-driven, cutting and etching, and for pass-driven, rastering. So that's how you should be mentally separating these two main types of processes. Cutting and etching are over here, rastering is over here. Cutting and etching is done by utilizing a graphics object called vector paths. Those are things like what I have illustrated here, so outlines of shapes, lines, outlines of text. Rastering, on the other hand, is done by using images or image files and filled in vectors that we've converted to images. Remember, that's that special case I was talking about earlier, where you're converting a vector into an image. And yeah, that is pretty much the conceptual framework of what we have done so far.
All right, now that we've discussed a lot of the theory and the actual functionality behind using Retina to control our laser cutter, why don't I show you the actual step-by-step process to use this laser? Let's do a simple project where we import a .svg file, or a line file, into Retina, convert it to an image, and then cut it out of some wood.
To start our project, we have to first load in an SVG file, like I mentioned earlier. In order to do that, we have to go into our Import Image tool, which again is on the far left side of our lower top toolbar. It's one of our light green tools. And we're going to click Import Image. And now I've already received an SVG file that I can use for this, but you can find an SVG file pretty much anywhere on the internet. You just have to Google search whatever type of logo or graphic you're looking for, followed by the words .svg. For me, it's going to be a picture of my company's logo, the 2-Bit Circus Foundation. So let's load it in, and it's going to process. And there it is. It's a little tiny, so I'm going to make it a little bit larger. And I'm going to do that by holding down Shift on my keyboard, pressing my left mouse button, and dragging out to make it bigger. There we go, and I'm just going to put it towards somewhere on my artboard. Yeah, that works for me. Now, you may have noticed that when I imported this SVG, it formed into two different colors. Sometimes SVGs import a little weirdly, and that will happen. If you want everything to be the same color, which most likely you do, you're going to go and just select one of the components of your SVG and then change it to the color of the other one. So I'm going to select my brown component, and I'm going to change it to the color of my blue component, which I believe is this one. There we go. And now, like we did before, we're going to convert this into a rastered filled image. So to do that, we're going to select everything, give it a horizontal lines infill in our vector fill and rasterize options, and then we're going to hit rasterize in the same section. And now it's an image, just like we did before. I'm going to increase its resolution to 500 by 500 dpi, like we did previously. And I know for my material, it works well when I'm running at about 60% power. So I'm going to do that, and I'm not going to touch speed, because remember, we try to keep speed at 100. Great. Now the last thing I want to do is create a vector that will cut out this rastered image into a sort of portrait or plate. So I'm going to go ahead to my shape tool, and I'm going to make a rectangle. And I'm going to go and just create a general rectangle that looks about right to me. And now it's been defined by its own vector color, orange. So I'm going to go ahead and make sure that it's set to parameters that I can use to cut my material. Because remember, this vector path, this orange vector that I've selected, its purpose is to cut out my rasterized image onto a plate. So looking at its vector engraving parameters, we can see that the speed is 100, the power is 100, the current's 100, and the passes are at 3. I know from my material that, again, this works perfect to cut material. So I'm going to leave it at this. And there you have it. That is the design that we will send out to the laser cutter.
Now that we've created our design, we have to load our material, in this case I'm going to be using balsa wood, into our laser. To load your material, you're just going to take it and place it onto the laser bed. I like to put it in the top left corner. Now that you've loaded your material, you have to focus the laser. In order to focus the laser, you need to first unlock it. Currently, if I try to move the laser gantry with my hands, I'm going to experience a lot of resistance. I will be able to move it, but I will be experiencing an extreme amount of resistance. You should not be moving the laser if you give that much resistance. That can risk damaging the motors. In order to prevent that, you're going to go ahead and click this button in the bottom left corner of the screen. It's a little lock symbol that says locked on it. When I press it, it unlocks my laser carriage. And I know it's unlocked because I get a blue alert saying laser head unlocked, and also all of my gantry control buttons have gone from blue to clear. Now, I can move my laser head freely, with no resistance whatsoever. Again, you should not move the laser with your hand if you are experiencing resistance. It can damage the motors. You should always make sure the laser head is unlocked before you do so. Once you've unlocked the laser, you can place the laser head somewhere above your material. I like to place it above the center. Now, in order to actually focus your laser onto your material, you have to use this tool. This is your focusing puck. It is a tool that you can utilize in order to focus your laser's Z height, so that way it gets the optimum strength when it hits the surface of your material. You must focus your laser every single time you put a sheet of material into your laser cutter, even if it is 2 pieces from the same stock. It is an integral process, and we recommend doing it every time by utilizing this tool. In order to use it, you have to do the following procedure. In order to begin focusing your laser, you have to first loosen the carriage for the focusing lens. In order to do that, you'll notice a brass knob on the side of the carriage. Twist that knob towards the laser, and you can pull the carriage up. Once you've done that, you can take your focusing puck and place it underneath the tip of the carriage. You'll notice that on the surface of your material, there is a red dot. To be clear, that red dot is not the laser itself. It is simply an LED indicating the position of the laser when it will be fired. The laser will not fire as long as the laser hood is open, which it currently is. Once you've placed the focusing puck underneath the carriage, you can push the carriage with the focusing lens down until its tip is touching the surface of the focusing puck. And after that, you can tighten up the brass knob by twisting it towards you. Once you've done that, you can remove the focusing puck, and now your laser is focused. Once you've focused the laser, you can now re-lock the laser head in order to recalibrate its 0 and home position and get ready to start your cut. In order to re-lock the laser, you go to the now unlocked icon, still in the bottom left corner, and you press it again. The procedure you just witnessed was the laser re-homing back to its 0 point. This ensures that your coordinate system will always be correct and ensures that when you try to cut something, it will be in the location you told Retina to put it in. You'll notice now that I've rehomed and relocked my laser, all of my controls have resumed to white.
Now that the laser has been focused and locked, we have to do one last preparatory stage. We have to run perimeter. When you run perimeter, you are checking to see if the boundaries of your design lie within the boundaries of your material. Basically, the laser will run in a rectangular path that encompasses the perimeter of all of your designs. If the laser is within the bounds of the material you've placed, you know you'll be good. If the laser goes past those bounds, then you have to go and correct either the size of your design or the location of your material. To run perimeter, you're going to click this gray icon in our laser preview toolbar set. That's a square. This is the run perimeter button. When you click it, it will go and start the laser's run perimeter procedure, which you can see in the following clip. So, once you have gone and focused your laser, locked your laser, and ran perimeter, you are safe to go to start your laser cut. All you have to do is go over to this play button icon and press play. And why don't we take a look to see how it's going?
Alright folks, before we wrap up today, I'd like to take a little time to talk to you about some general classroom tips I recommend using for your laser cutter to help streamline the laser cutting process and also make sure all your kids get a meaningful experience out of it. Firstly, I highly recommend making it so that way your students create their designs on the demo version of Retina Engrave. This is an online, disconnected version of the Retina Engrave software that is not linked to any laser. The suggested method is to have them create their design in the demo software and then export it as a file to either a flash drive or their own email. Then they can go to a designated workspace that is connected to the laser and actually perform their laser operation on that computer. This way it makes it so that way not too many students are on the laser system at one time and no one accidentally starts or stops a laser cut. If you would like to access the demo software, you can find it on fslaser.com/software. Regarding materials for your classroom, there is a very wide range of materials that are safe and encouraged to use within laser cutters. There's also a very large list of materials you should not use in laser cutters. To know the difference, you can go online to search approved materials for my laser cutter, and you'll be able to find a very, very long set of lists of documented materials and their power settings, so that way you know the optimal setup for cutting specific types of material. If you're having any problems with your device, we highly recommend contacting the manufacturer, Full Spectrum Laser. They have a very expedited support system that can make sure you're helped with any technical issues pretty quickly. Finally, while rasters are a really great tool that can teach kids a lot about the whole idea of digital to physical information conversion, we have to be mindful of the fact that rasters, because they are pass-driven, not path-driven, take significantly longer than any type of vector operation. As a result, we recommend to keep rasters for a full-size class of students to around maximum 2 inches by 2 inches in dimensions. This will keep the raster length to roughly less than 10 minutes per cut. Alright everybody, that's all I had to say for today. Thank you so much for tuning in for this long. Once again, I'm Ash with the 2-Bit Circus Foundation. I've had a wonderful time telling you all about the world of laser cutting, and if you have any questions, please reach out to us at the 2-Bit Circus Foundation.